Yo, what's up? We are now sitting in a BMW i4 eDrive 40, and today I will have a little rant, maybe not rant, but a little chat, like a podcast thing. Yeah, and I realized this is the perfect moment. We are now doing the OnlyFans run with the BMW, and we have a little chat with the live stream now about 400 volt versus 800 volt, and I think I want to make a new updated video about this, because I made a video maybe, I think it was 2 years ago, and my claims still stands about it. That my claim is that 800 volt cars like Taycan, like Ioniq 5 is a gimmick. It's a hype. It's not really necessary yet, but in the future it will be. So where do I start? Okay, I have to explain first the physics, the fundamental laws behind it. So when you know a little bit of electronics, right? You have probably had it at school, and you know URI. U is voltage, R is resistance, I is current, and if you lower, if you increase the voltage from 400 volt to 800 volt, you can then lower the current and you get the same power. That's the whole fundamental rule behind it. So for example, if you need to charge at 100 kilowatt, you can then lower the you raise the voltage and then you lower the current, and then because you lower the current, you will then have less resistance, because you have to square the current multiplied by R resistance to get heat loss. Okay, fair enough, but think about this. Where is the heat loss really? If you look at the battery pack, each cell is it depends which chemistry, but typically 3.7 volt nominal, something like that. So the Taycan battery pack or the EV6 battery pack, they still consist of those 3.7 cell units, the smallest unit, like the atoms almost, right, in the battery pack. But you just arrange it differently so that you get 800 volt for the whole pack rather than 400 volt, right? So that means that, and also you guys probably know it, when you discharge a cell, you will have some losses. It will generate some heat, and also when you charge a cell, you will also generate some heat. That means that cell doesn't know that it belongs to an 800 volt pack or a 400 volt pack. It will still behave as it's supposed to, which means to just give out heat. So, and that's my claim, is that the biggest heat loss in an EV is actually the heat loss generated by the motors and the battery pack. So the motors should be more efficient since they are 800 volt system versus 400 volt. But the battery pack is still the same cells, the same fundamental building blocks. So, and that's also where lots of kilowatt is lost when you discharge it or charge it. And what about losses other places? Well, you have losses in the cable going from the charger to the car, but how many kilowatt are we losing there versus how many kilowatt we lose on the battery pack? I think typical in the battery pack, when you charge it or discharge it, you could lose somewhere between 2 and 5 kilowatt. Maybe 5 is a bit high unless you hammer it. But in a cable, I haven't checked this, of course, but I don't think you can lose several kilowatt just in a cable. It must be lower than that, because I'm just assuming now, I don't know really. But my claim is that the losses that you have in the 400 volt system is not that much more than the 800 volt. And I've done some tests actually with a Model 3, which is 400 volt based, versus a Taycan. I did some charging tests and I tried to measure how much losses you had, and I checked it against what the charge point operator reported delivered from the charger, and I found out that Model 3 doesn't have that much more loss than Taycan. I think, I don't remember the numbers, but let's say Model 3 had 9% loss and the Taycan had 7% loss, something like that. You know, it's not that much. But you have to also consider something else loss. The Taycan since it's 400 volt based system, once it needs to charge on 400, sorry, the Taycan is 800 volts, sorry. Once the Taycan needs to charge on 400 volt system, it needs to convert 400 volt up to 800 volt. And Taycan has this onboard DC-DC converter, steps up the voltage, and some people here claims that it has 98% efficiency. All right, fine, but if you're charging at 100 kilowatt, you still have 2 kilowatt loss there in just that conversion step, but you also have losses other places, like I mentioned, within the cell, within the cable and all that. But that is 2 kilowatt extra loss, or 3 kilowatt if you're charging at 150 kilowatt. That's 2-3 kilowatt extra loss that you don't have if you have a 400 volt based battery pack, like the one I'm sitting in right now in the BMW i4. It's 450 volt voltage. So when you think about this, okay, the Taycan might have lower losses when they're charging at 800 volt, but at 400 volt it will have more losses. So overall, over the total lifetime, Taycan and this i4 might have the same amount of losses. So which means that the argument about, oh, you have lower losses is not really valid. That's my point. And then what about the argument about, yeah, but when you have a maximum current of 500 amp, Taycan can charge at 265 kilowatt because the voltage is higher and it doesn't, yeah. So yeah, you know, okay, let me explain how it works. Battery packs will typically have around 400 volts, which means that in the CCS2 standard, that goes up to 500 volts, 500 amps for most cables. Then you are capped at roughly 200 kilowatt. But in order to get 200 kilowatt and 500 amp, you have to have 400 volt. Many cars like Tesla, at low state of charge, you don't have 400 volt at the bottom, you have only 360, 370 volt. So you don't get 200 kilowatt from the bottom. But for example, this car here, the BMW, has roughly 400 to 450 volts. The same goes for Tesla Palladium, which includes the Plaid and the new long range. They also have 400, 450, whereas older Teslas, they tend to go from 350 to 400 volt. So actually, if you just design the battery pack to have 400, 450 volt, then you kind of overcome some of the disadvantages with the 400 volt system versus the 800 volt system. And not only that, when you look at Taycan, when Taycan is pumping in 265 kilowatt, which is peak, then it can keep that one for a limited time, and then it starts throttling. And by the way, why is Taycan not charging at 350 kilowatt? Well, because it will fry the battery. And even at 265 kilowatt, it seems like it might also kind of fry the battery-ish, because there is an option in Taycan to limit the charging power to maximum 200 kilowatt for saving the battery or something like that. Si nej till vindkraft, okay. So why? Well, actually, when I look at that feature, it's like, I don't remember what it was called, but not only does it limit its speed to 200, you actually get 200 kilowatt just briefly then, but it will actually make the whole charging curve slower. And not only that, but the temperature in the pack, normally you will go like 55, almost 60 degrees in the pack when you're pumping in 260 kilowatt, right? When you have the eco charge on, it will go to a roughly 40 degrees only. So Porsche engineers figured out that the way they charge it at maximum speed is killing the battery. So in order to preserve the battery life, you have to go slower, which means that Taycan might as well be a 400 volt based system, because it's only taking 200 kilowatt initially, and then it slows down even more, just like this car, which is already 400 volt based. And one other thing is that when we talk about those 800 volt cars, you think, oh, but it's twice the voltage, half the current. It's actually not entirely true, because Taycan at low state of charge, I don't remember the voltage, but I think it's below 700, whereas this car is at low state of charge, it's at 400 something, 405 maybe, 410. So it's not double. It's more like 80% higher. So which means that the difference might not be as big as you might think. So the whole argument that with higher with higher voltage you can go higher. Well, the problem with today's packs is that the tech is not there yet. The battery pack is not big enough. Okay, I've seen it on trucks. You guys have seen it on my video on my channel also. It was the Volvo truck. I think it was at 90%. It was still pumping in 200 kilowatts. It's awesome, but that battery pack is huge. You know, I don't remember how big it was. Maybe 300, 400 kilowatt hour. So of course it can go with that kind of speeds then. But cars nowadays, you know, not trucks but cars, they don't have that big battery packs, which means that the limitation or the bottleneck is within the battery pack, not in the volt architecture. So you know, Taycan doesn't pump in 265 kilowatt all the way to 80%. It will probably fry the battery or kill it very fast. And even, you know, even one day when we have better battery tech, if 150, 200 kilowatt hour is more common, or if we have some kind of super battery out there, then we could even get away with 400 volt based system. Like this car, for example, at low state of charge, it can take 210 kilowatt. And then at high state of charge, close to 80%, it can take roughly 220 kilowatt. Think about this. If you can charge 210 to 220 kilowatt from 10 to 80% flat, that's massive, right? Well, of course, if you go 800 volt, you can lower the current and then you can minimize the losses. So, but you know, I'm not saying that 800 volt is useless, because it's not. What I'm saying is that 800 volt is just hyped up. It's not ready yet. Another problem I mentioned was the conversion. To put it this way, the problem with 800 volt car is the 400 volt chargers, because they have to make sure that the car is backward compatible. And as for the Taycan's case, they use extra hardware to convert 400 volt to 800 volt. It's a two times step up converter. That's my claim. By the way, they don't split the battery pack in half and charge both of them half. They don't do that. Some people believe that that's how it is, but it's not like that. Wait, I need to coast. Okay, I'm gonna coast a little bit now. But you see, wait, I'm not picking up speed. Okay, no, it's not there yet. Okay, but the problem is the 400 volt chargers, because you have to make sure that the car can deal with that. Or I mean, Porsche and Kia, Hyundai, they could just say, screw it. This car can only charge at 800 volt. But then you lose out a lot of flexibility. In case you have to charge on 50 kilowatt, then it's like, sorry, Mac, you can't do it. Yeah, so it's a compromise. That's what I'm saying. That car, the Porsche, has extra weight. Whoa, burn. Okay, that car has extra weight and cost and complexity and extra cabling or whatever, so it can deal with 400 volt chargers. So in an ideal world, we need to get rid of all the 400 volt chargers. So we only have 800 volt chargers out there. And then car manufacturers can make future EVs to only support 800 volts only. So yeah, that's the solution. Get rid of those old ABB 50 kilowatt chargers, those tritium 50 kilowatt. Replace them with only 800 volt, and typically there will be HPC. So it's more desirable today to have HPC anyway. 50 kilowatts kind of old tech, mainly also because one big problem with the 50 kilowatt chargers is that that plug is rated for 125 amp. So in order to get 50 kilowatt, you have to have 400 volt at low state of charge. And as I mentioned, many cars nowadays, they don't have 400 volt. So practically they will get only as low as 35 to 40 kilowatt at the bottom, not 50 kilowatt flat. But this car, for example, will get 50 kilowatt flat because the voltage on this car is roughly 400 at the bottom. So that's the solution. But then we have so many 50 kilowatt fast chargers out there, and even in no man's land there will be plenty of 50 kilowatt there. They just need to get rid of that 50 kilowatt and replace it with some kind of 800 volt, maybe with some power sharing, delta charger, for example. So they might pull the same amount of power, let's say maximum 100 kilowatts. Well, typically a site might have 250 kilowatt chargers, so it must have roughly 100 kilowatt available. So there's got to be a better way to just install smarter hardware with some load balancing or something, and allow 800 volt cars to charge there without having to convert. But it's going to take some time. You know, it will take a long time to get rid of 400 volt in the whole Europe, and until then car manufacturers must make the cars compatible, backward compatible, and that is a disadvantage. When it comes to the Korean cars, they have a better, actually way better system than Porsche, which is that, I know it's called Porsche, but I'm just trolling you guys. Which is that they actually use the inverter or something. I don't know, but inverter is for AC-DC. This is DC-DC. I don't know how it works. Maybe the inverter part has some kind of DC-DC converter also, plus some AC-DC or DC-AC. Yeah, but the Koreans, they did something smart. They use existing hardware to then do the conversion. And one thing I forgot to mention is that the Porsche has a limitation of, well, it used to be 50 kilowatt unless you paid extra to get 150 kilowatt onboard converter. So in a Porsche, you can only go maximum 150 kilowatt on 400 volt. Whereas for the Korean cars, you can go higher. Supposedly the limitation is within that rear drive unit of the EV6 and Ioniq 5, and I've seen it that it can output, when we hammer it, you can output 230 kilowatt roughly, which means that, speaking of Ioniq 5, here we have an Ioniq 5, yoo-hoo! So it means that the Ioniq 5 should be able to take 230 kilowatt and convert it to 800 volt. But then where do we have those chargers? Well, Tesla supercharger V3 is 250 kilowatt, 400 volt base. Other than that, more than 150 kilowatt, 400 volt is not very common. But fortunately, Alpitronic or Hypercharger. Alpitronic is the manufacturer, Hypercharger is the product. Hyperchargers are 800 volt only. ABB HPCs, they are also 800 volt, 800 and 920 volt only. Delta chargers, which is also common, unfortunately they have a 400 volt option, I think by default, and then you have to pay extra to get 800 volt architecture. Kempower is 400 volt as of today, but they already have 800 volt architecture they use for buses, and they already have a solution where they can upgrade existing they can upgrade existing 400 volt sites to be 800 volt without having to dig anything. They just change some hardware in the charger stack, and then voila, 800 volt. So you see, we just have to slowly move over to 800 volt, pure 800 volt only. And okay, maybe in the future it doesn't have to be 100% 800 volt all over Europe. It can be 99.9%, and then for the few 400 volt chargers you find, then just whatever, screw it. It's not important, because as long as you have enough 800 volt chargers all over the place, then no problem. So my claim again is that the 800 volt architecture thing, whatever, as of today, it doesn't have any advantage. That's my claim. And if you look at, for example, the 1,000 kilometer challenge, which is like a practical test, right? A real world full stack test, you will see that cars with 800 volt architectures, they don't dominate the 1,000 kilometer challenge. It's actually mainly dominated by Tesla, 400 volt based. And even this car here, the BMW i4, managed to do 1,000 kilometers in 9 hours and 20 minutes, which is really fast. And it is actually faster than the e-tron GT and the Fat Taycan. And okay, it's kind of unfair because the e-tron GT and Fat Taycan, they had fat tires, but even if we put skinny tires on those cars, then we might get also 9 hours and 20 minutes on those 800 volt cars, which goes back to my point again that then it means that the 800 volt architecture has no advantage over the 400 volt then, right? Since they can have the same time, So, yeah, I don't know if this makes any sense for you guys. Just try to give you guys all the information. So my claim still stands that 800 volt is a gimmick today, but just give it, I think in roughly 5 to 10 years, then 800 volt will make way more sense because we will have more and more. Let me see, check over here. Let's see, this site we're driving past right now, it has those old ABB, I can see that, is that ABB FSX? Yeah, I think that's the ABB charger. So it has 4 times 50 kilowatt, 400 volt based system. But, oh, here we have supercharger to the left here. Oh, nice. But we also drove past some HPC at Circle K, and those are 800 volt based. So, we just need to have enough 800 volt based system out there, and then we could just scratch 400 volt. Yeah. So, but again, I have to repeat again that I am not against 400 volt. I believe that, I'm not against 800 volt. I believe that 800 volt is the future. We have to get there eventually. But as of today, then, yeah, 400 volt is still working fine. And then the good thing though is that even in the future, when we have only 800 volt systems, then the 800 volt chargers, they are backward compatible with 400 volt cars. So even this car here that I'm driving today will work fine in 20 years. But so then, but wouldn't it be better to move over to 400 to move over to 800 volt as soon as possible? As far as I know, I don't see any benefits today, really. Like I said, it's too early. And if this car was designed to be an 800 volt car, then it needs to have some kind of extra architecture or some kind of extra hardware or something, logic, which costs extra money for development, for hardware, for weight, maybe even to support 400 volt. So again, my claim is that cars should just stick with 400 volt for maybe 5 more years, and then maybe move more and more over to 800 volt. So yeah, what else is it to say? I can already, by the way, now say that even today, like this car here, the i4, when I took it on 1,000 kilometer challenge, I was kind of struggling. Oh, what was the struggle about? Well, the struggle was about that the car charged so fast. So I barely had time to eat anything. It needed roughly just 10 minutes to go to about 40%. And so if I would take a food stop, I would be at almost 100%, or at least 70, 80%. And then with this car, which is efficient, then I have plenty of range. So, by the way, another thing I should highlight is that when people talk about, oh, efficiency, oh, losses, you know, in 800 volt, 800 volt, in my opinion, is like a bad excuse for making the car look better than it is. What car manufacturers need to put the R&D money into 77 kilometers per hour. What car manufacturers need to focus on is, like Tesla has been doing, like many of the Korean cars have been doing, they need to make the cars more efficient, because efficiency trumps it all. With more efficient cars, you can get away with smaller battery, you can get away with not so fast charging, the battery will be lighter, you will have better acceleration, better braking, better handling, better consumption. You need less rare earth materials. So try to make the car more efficient, make the car more aerodynamic. Screw that fossil-like grille. make the car light and aerodynamic, and also look at the drivetrain. Try to reduce friction in gearbox, in whatever joint, whatever you have there, and make the car more efficient, because the car I'm driving right now is super efficient. We average 135 watt-hour per kilometer now since Oslo, and I think we also went, we are at a higher elevation, and also we have headwind. So this BMW weighs 2,200 kilograms. It has 340 horsepower rear-wheel drive, but it is roughly as efficient as a Model 3, and it's more efficient than many other cars in the same class. So really, instead of like wasting your money and time on 800 volt system, which is a compromise, then go for a more efficient car instead, and you will have way bigger benefits, really. So I think that's gonna be it. I have to focus. There was some slope. Whoa, what the heck is this? Oh, what the heck? Oh, they might be smelly. I want to overtake them. I'm gonna go a little bit faster. Wait. Okay, now we get to the point where I shouldn't overtake. Oh shit, they are really smelly. And this car doesn't filter much. Okay, I have to hammer them. In the downhill here, I will hammer them. Some kind of tourist with some Vespas or whatever. But yeah, so again, I'm not sure what else. You guys, I guess once I post this video, there'll be lots of arguments. I heard some arguments in the live stream earlier, yesterday. They were like, I listened to the engineer more than you. Sorry. Well, okay, fine. I'm just basing. I'm actually also an engineer, by the way, a computer engineer, but I'm not a mechanical engineer or electrical engineer. But at least I base my claims and consumptions on actual test, real world test all over the world about actual driving and everything. Okay, I'm gonna go a little bit faster. Okay. Oh, that was freaking fossil smell. Yeah. Okay. Now we're gonna go back to Sunday driving. So yeah. I don't know if it makes any sense for you, but I try to make clear arguments and discuss it in the most rational way, and not hide any details. We highlight the pros and cons on both systems. And yeah, I don't know what you guys think, huh? Does it make any sense? Or am I just bullshitting? Because trust me, I have no agenda against 800 volt based system. Okay, Tesla just happened to have 400 volt. But eventually, I think also Tesla needs to move over to 800 volt. But as for now, it kind of works. We just have to get better batteries and I guess more chargers out there, and then it will kick ass for the Lord with 800 volt. Yeah. So yeah, I think that's gonna be it for now. I hope you guys enjoyed this video. As always, thank you for watching, and talk to you later.